I told you that there is different model demonstrate relation between adsorbent and adsorbate. The most popular two models are Langmuir and Freundlich, but there is a linear and peak models. I will not go through these models. I will concentrate only in Langmuir and Freundlich model. Freundlich isotherm is an empirical equations. However, Langmuir isotherm has a rational basis. We will focus on these two equations or models. This is a mathematical models or equation used to describe behavior of absorption process. As I told you that Freundlich is an empirical equation. Freundlich and Langmuir are widely used in soil chemistry. This is the Freundlich equation. Q, amount of adsorbate, mole per kilogram. K is a distribution coefficient. C is a concentration of adsorbate at equilibrium in the solution after shaking. C is correction factor. So if you have 1 over n, if 1 over n is intensity of adsorption, higher 1 over 10 value means that more favorable absorption and more favorable absorption between adsorbent and adsorbate. There is a high affinity if 1 over n is more than 1. If 1 over n more than 1, then n should be less than 1. Here, if there is n less than 1 or 1 over n more than 1, here if it is more than 1 here, then the C will have a high value if it is 1 over 1. Consequently, there is a high affinity between adsorbent and adsorbate. If there is n equal 1, then you will have a constant relation or C shape. Here is a Freundlich shape, or as I told you, it is an L shape. It's L shape if it is more than. If it is less than 1, so it is less favorable relation between adsorbent and adsorbate, but it has this shape. If you would like to convert the Freundlich Langmuir to a linear Langmuir to calculate n and k easily, here is difficult to calculate n and k to describe if there is a high affinity or low affinity. You have to measure n here. Is this correct? So you can easily convert this equation to linear equation by multiplying by applying log for each side of the equation. If you to convert this to a linear equation, then the log q will equal log k a plus 1 over n log c. I think it's easy to convert. Here is like y equal a plus bx. Q is amount of sorbent as an element. C is equilibrium at concentration. K is and N is empirical constant related to sorption phenomena. So if you plot log Q, if you plot log Q and log Q in y axis and log C in x axis, you will obtain a linear if you plot log Q and log C, this is a linear equation like y equal a plus bx. So if you plot log Q on y-x and log C on x on x-axis, you will obtain a linear a line. The intersect point between the line and the y-axis will equal to log ka, while the slope will equal to 1 over n. So log C, do you remember the experiment which was conducted here? Remember here? You put the adsorbent and adsorbate on a series of concentrations and shake. After shaking, you make filtration and take the supernatant, a clear portion here, and measure the remaining concentration. Okay, you calculate Q by this equation. Are you remember by Q here? Q small or sometimes called Q capital or Q small. Maybe like this or like this. So Q by this final, as I told you, while C is a final concentration after shaking here. You have a series. So after you make this experiment, then you will have two parameters. You will acquire two parameters. The first is C and Q. It's obtained. Now you want to calculate to obtain K and N, 1 over N, to help you know if the absorption if the relation between adsorbent and adsorbate are favorable or not by calculating N and K. If 1 over N less than more than 1, then it is favorable, and vice versa. Okay, so here imagine that you have a log C on a table and a series of log C, 2, 4, 6, and so on, and a series of log Q. It's easy to obtain. Plot it on a line. The intersect point is log K, while the slope, it's easy to calculate the slope. Isn't this difference between 2 points in y-axis and 2 points in x-axis? You will obtain the slope easy. The slope will equal 1 over n, then it's easy to calculate 1 over n. If it is less than 1, the plot concave with respect to the c-axis and the absorption is not favorable. If it is equal 1, then the linear, in this case K is called distribution coefficient K. If it is more than 1, then the absorption will be favorable, like here. If it is more than 1, higher 1 or more favorable. Is this clear? Okay. The second model, as I told you, the Freundlich is empirical equation, while Langmuir is rational basis. Langmuir equation was also used in soil chemistry, and first time used in 1956, and based on the following assumption. The first is absorption occur on the surface that has a fixed and similar number of absorption sites. The second is this absorption site can only absorb one molecule to form a mono absorption layer that represents the maximum value of absorption, so only one layer. Absorption is reversible process, the absorption capacity is equal to all sides and is independent from the absorption sites, and the surface is homogeneous. Furthermore, is that there is no interaction between the absorbed ions. Okay. This Langmuir, the final version of Langmuir, C is a concentration at equilibrium. Q, as I told you, is the amount of absorbed element on the absorbent. 1 over K is a constant. Absorption constant related to bending energy. X max is the maximum. Here is very important to calculate X max. Means the maximum ion absorption maxima or a maximum capacity for absorption. It means that the maximum amount of adsorbate can be absorbed to adsorbent. The maximum amount of contaminant can be absorbed to a solid material. A maximum amount of element can be absorbed to the soil, for example. So here is the importance of Langmuir, to that you are able by using this equation to calculate the maximum absorption, while in Freundlich it's not allowed to calculate the X max. So here, if you plot C on x-axis and C over Q on y-axis, you will get a linear equation like this. So if you have C over Q like y, 1 over K x max is A plus C over plus 1 over x max is B, C is X. So the slope here the slope is B, should be 1 over max. Is this correct? Yes. And here is the intersect point. If the intersection here is in 10 or 9, then 1 over K x max will equal 9. Calculate the slope. The slope will equal to 1 over max. If the slope here, for example, 2, then over 1 over max equal 2, then x max equal half. If you obtain x max, then it's easy by using this equation. 1 over max, 1 over K x max equals the intersection point. If the intersection at 9, then 1 over K multiply half equal 9, then it's easy to obtain K, the bonding energy. So by using these Langmuir equations, you are able to calculate bending energy and X max, the energy, the bending between two adsorbent and adsorbate. Okay, then we finish now the two last models. I hope to be understandable, and thank you.